Good morning, students. In the earlier sessions of the same chapter, differential equation, I have taught you about the degree and the order of the differential equation, and to solve the equation by the first method, which is known as the variable separable method. That means the two variables x and y can be easily separated, of course, by dividing or multiplying the terms here given in a particular problem. Then we try to find the solution, that is integrating. Integration has to be done to get the solution. So that gives you the general solution. So when a particular values of x and y have been given, we substitute and get the value of the arbitrary constant, which is called as the particular solution. Now I am moving on to the second method, which is known as the linear differential equation. This type of problem you will be given for a 5-mark question in part D. Now what do you mean by a linear differential equation? See, be an equation, a differential equation of the form dy by dx plus p into y equal to q. So, any differential equation of this particular form, it has to be in this form only, we call it as a linear differential equation. Dy by dx plus p into y equal to q. Next is, what are p and q? P and q, they have to be either constant. Okay, there are two options, there are two possibilities. They can be constants, that is some number 3, 4, 5, 7, something like that. So, P and Q may be constants, or they have to be functions of x only. It cannot be an implicit function like combination of x and y. Either they have to be purely functions of x. It should contain only x, or they have to be constant. So, these are the two possibilities. Either they would be constants or functions of only x. That is important here. Such equation is called as a linear differential equation. Our problem is not the definition of a linear differential equation. Our problem is how to solve the linear differential equation. Here this procedure is a little bit lengthy, that is why it has been given for a 5-mark question. Now here, as soon as suppose equation is directly in this form, it is well and good, you can get the values of p and q. Suppose it is not so, you have to bring it to this particular form. Suppose I am having here x into something divided by x, or dx is here, rearrange the terms in such a way that the function, the equation comes to this particular form only. Dy by dx should be separated, whose coefficient is unity, plus some function into y, that function should contain only x here, or it has to be a constant, and q would be either functions of a function of x, or it would be a constant. If it is directly not there, bring it to that particular form. Then so what is p, what is q, you have to find out. When it has come to that form, why write what is p and what is q. Then here first step is find the values of p and q. Okay, identify the values of p and q. Second step is integrate p into dx. P is anyway either a constant or a function of x. No? Integrate, this is the second step. First step is identify p and q. Second step is integrate p with respect to x here. Then the third step, here we use a word, integrating factor. Okay, this you have to remember, integrating factor. Generally we write in the short form IF, capital I, capital F here, integrating factor. What is an integrating factor is e raised to the power p into dx. That is why I told you to calculate that particular part. So, integrating factor is e to the power. First you find out, then raise it to the power, whatever has been already calculated. Then the solution is obtained like this. You have to by heart these things. P and Q, of course, looking at the equation you can get the result. Even this has to be written, this has to be calculated by you only, and your integrating factor definition is e to the power integral p dx. Then the solution is y into the integrating factor on the left hand side. Directly you write here y into the integrating factor, that is equal to integral whatever is q, you write q into the integrating factor into dx plus the constant of integration. Okay, this is the solution. So it is a formula which has to be remembered by you. So as soon as you get the values of p and q, first integrate p with respect to x, then the integrating factor is obtained by raising e to the value already which has been calculated. So then this is the integrating factor. Then the solution is obtained by this formula, y into the integrating factor, that is equal to, so left hand side no integration, directly we are writing, right hand side q, the right hand side part of the given equation, into, again you write the, don't cancel this integrating factor, because you see that on either side of the equality sign, you cannot do that one, it is an independent term, whereas here it has to be integrated. So q into integrating factor into dx, so this has to be integrated. Here looking at the function, we have to decide what method of integration. It may be, suppose it is a simple function, directly you can use the basic integrals, the standard integrals, or you may have to use the substitution method, or you may have to use the integration by parts, or you may have to use the integration by partial fraction. It depends upon what terms we are getting here. So this is the procedure we adopt. So first bring the equation to this form if it is not given in that form. That means it dy by dx has to be separated plus p into y equal to q. P and q should be functions of x, or they have to be constants. Find what is p and what is q. Then find integral p df. Then the p dx. Then integrating factor if is e to the power p dx. Integral p dx. Then the solution is given by this one, y into integrating factor equal to integral of q into integrating factor into dx plus the constant. So this part has to be integrated. So this is the procedure we adopt to find the solution of the linear differential equation. Of course, each step carries marks here. So don't skip any step here. You have to solve the problem step by step. First we will calculate the general solution. Afterwards we will come to the particular solution. So find the general solution of the first equation. dy by dx plus 3 into y is equal to e to the power minus 2x. Now this is clearly, you see that it is in the form of a linear differential equation. dy by dx is there plus 3, p is 3 and it is a constant here, and q is e power minus 2x, it is a function of x. So it is in this problem I have given you directly in the standard form. So first we will identify what is p and what is q. What is p here? P is 3, q is e to the power minus 2x. First step. Next is consider what has to be considered? Integral p into dx. What is p here? That is integral 3 into dx. 3 being a constant, you can keep it outside, integrate dx, that is x. Therefore, integral p dx is equal to 3x. So one step is over. Next is, what I should get here, next one, the integrating factor. So write here the integrating factor. You can write, use this notation if only, that is e to the power integral p dx. P dx has been calculated already. That means e to the power 3x. So this is the integrating factor. So first what I have done? I have written the values of p and q and I have calculated integral p dx, which has become 3x here. I have calculated the integrating factor, which is e to the power integral p dx. In this case it has become e to the power 3x. Next is the solution. So I told you solution is, first you always make the habit to write the formula. Y into integrating factor is equal to integral q into integrating factor into dx plus the constant. Okay. Now what is the integrating factor? Let me write, that is y into e to the power 3x that is equal to, what is q? E to the power minus 2x. Here e to the power 3x into dx plus the constant. So when once we write the value on the left hand side, that has to be kept as it is. We need not do anything because it is an independent term here. I mean without the integral sign. Only the right hand side has to be integrated. Now here it is of the form a power m into a power n. That means that we are using the first law of the indices. It is e to the power 3x minus 2x into dx. What is 3x minus 2x? It is e power x into dx plus the constant. See, we have got the basic function here. What is the integral of e to the power x? It is e to the power x plus the constant. So, y into e to the power 3x is equal to e to the power x plus the constant. See, you can stop here itself. Okay, you can this itself is the solution here. Or generally, I have told you already in when I start one of the earlier problems. Generally, we try to write the function as y is equal to fx. So if you want to write that one, first you have to divide by e to the power 3x, both the sides. In that case, now what happens here? It would be equal to, y would be e to the power x divided by e to the power 3x plus c divided by e to the power 3x. Then using the law of the indices, y can be written as e power 1x minus 3x is e to the power minus 2x, c into e to the power minus 3x. So this that is to express the answer in the form y is equal to fx, that the usual way of expressing I am using in this particular problem. Otherwise, you can stop here itself, y into e power 3x. I told you in all the problems by dividing it does not come to a very simplified form. In this problem it is better. Therefore, I have divided by the left hand side coefficient and written the answer as y is equal to fx in that particular form. So this is the way, the method to solve the linear differential equation. So always as soon as the equation is given, if it is given directly in the standard form, it is advantageous for us. Otherwise, bring it to the standard form, identify what is p and what is q, then find integral p into dx, that is important. Then the integrating factor is obtained by the formula e to the power integral p dx. In this problem it could not be simplified, I kept it as e to the power 3x only. Sometimes we can simplify that also. When I come to particular problem, you will know how it is possible. Now let us move on to the next problem. The next problem is dy by dx plus y divided by x is equal to x square. X is not equal to 0. X is not equal to 0. Okay. Now, in this problem also, it is almost in the standard form. You can see dy by dx is their individual term, and y by x and x by, it's a function of x, and y by x. Now let me make it clear by expressing in this form. Let me write it as 1 by x into y, that is equal to x square. So that it is of the form dy by dx plus p into y is equal to q here. Now what is p here? P is 1 by x and q is x square. Okay, q is x square. So what has to be calculated? I told you already. First we have to find out integral p dx. Now integral, what is p in this case? 1 by x into dx. In the earlier problem it was easier because we had only integral dx. Here integral 1 by x into dx. What is the integral of this one? It is log x. See, whenever we write the logarithmic term, strictly speaking we have to write the base. But these days even in question paper or even textbook also that is omitted. But that does not mean that there is no base at all. Base would be there. Usually if the base is e, they omit it. We have to understand that the base is e there. So this is integral p dx. Okay, that is equal to log x to base e. Now we have to calculate the integrating factor. What is the integrating factor? E to the power integral p dx. That is why I have asked you to calculate the first. Now write what is integral p dx. E to the power log x to base e. When I was teaching you about the logarithm, I had given some information. Apart from the 4 laws of the logarithm, I had given you one more information that always is helpful. You have to remember that one. E to the power log x to base a is always equal to x. This fact always you remember. It's an important information. Need not be e here always. It can be a. See the reason here, this exponential base and the logarithmic base, if they are one and the same, if the index is a logarithmic function, whatever term is there, that can be written directly. Actually, that is obtained by taking logarithm on both the sides here. So that explanation we don't go directly right. Suppose I am having here sin x, you can write it as sin x. If it is cos x, you can write cos x. Need not be always the base is e, but these two bases should be one and the same. Then whatever may be the function that we have taken logarithm of that one, it has to be written directly. Okay. So I am using that fact here. So e to the power log x to base a, I can write it as x only. That is, the integrating factor in this case is a very simple function, x we got. Now let me write the solution. First always write the formula. Y into integrating factor equal to integral of q into integrating factor into dx plus the constant. Now write y into integrating factor. In the previous one it was e power something, whereas here it is a basic function y into x, that is equal to, what is q? Q is x square, integrating factor is x into dx plus the constant. So x square into x, what is that one? X cube, isn't it? That means integral x cube into dx plus the constant. See, again we got a simple function, x to the power 3. It is also from x to the power n. So what is the integral? X to the power n plus 1 by n plus 1. So it is x to the power 4 by 4 plus the constant. This is y into x. Again I told you, you can keep it as it is, or you can divide by x, just to keep only y on the left hand side. So when you divide by x here, x to the power 4 becomes x cube divided by 4 plus c divided by x. Okay. So this is the general solution. So y is equal to, or you could have kept it as xy equal to this itself still, or you can do one thing, cross multiply 4xy equal to x power 4 plus 4c, even that is also correct here. So just to have only y on the left hand side, what I have done is I have divided by x, the coefficient of that one, and then I have written the answer like this. It is x cube divided by 4 plus the constant c divided by x here. So this is how you have to solve the problem. Here the number of steps is more compared to the previous problem. It is more because it has more of calculation. First you have to find what is p and what is q. Then you have to find out integral p dx, and then you have to find out the integrating factor, which is e to the power integral p dx. Then we have to get the solution, isn't it? Therefore you have to solve it. You have to write all the steps properly and you have to solve it carefully. Okay. Now let me move on to the next problem. It is dy by dx plus y into secant x is equal to tan x. Y into secant x equal to tan x here. Now some specific values have been given for x here. That is, an interval has been considered. So we are considering this equation only in the particular interval. What is that interval? 0 less than or equal to x less than pi by 2. That means it is a closed open interval 0 pi by 2. Why that pi by 2 has been omitted is, you know that tan pi by 2, though we write as infinity, it's not defined. Same thing with the secant pi by 2 also. So that value has been omitted. So we are considering the values of x in between 0 and pi by 2. 0 is included, pi by 2 is excluded. You clearly see that this problem also already in the standard form. Therefore, we can directly write the values of P and Q. P is secant x, Q is tan x. Here both of them are trigonometric functions. So when you do the integration, you have to remember the formulae or the standard integrals of the trigonometric functions. Now let us consider integral. You write everything properly. Consider integral P dx. Okay. Now integral P dx means integral secant x into dx. What's the integral of secant x? It is log of secant x plus tan x. So actually, of course in the book also they have given in the modulus sign, that is log of modulus of secant x plus tan x. The why we write that modulus sign is, when you take the logarithm of a positive number, it is a real number, real quantity. Suppose this is a negative number. Logarithm of a negative number becomes an imaginary quantity. Since we are discussing only about the real functions, that has been omitted. That is why they generally use the modulus sign here, logarithm of modulus of secant x plus tan x here. Now this is the integral. Now consider the integrating factor. What is that one? Write the formula here also. E to the power integral P dx, e to the power log of secant x plus tan x to the base e. Just now I told you in the previous problem, there also we had come across a logarithmic function. So e power log of some function to base a. This p and this base, they are equal to each other. Therefore the value becomes only secant x plus tan x. Hence the integrating factor is, in this case, secant x plus tan x. Okay. So we got the integrating factor. Next is directly we can go to the solution. What's the solution? Y into the integrating factor is equal to integral q into the integrating factor into dx plus the constant of integration. Now write the integrating factor. See, in the earlier problems, no, the integrating factor was comparatively smaller function. Here it is sum of two functions, secant x plus tan x, that's equal to integral q. What is q here? Q is tan x into secant x plus tan x into dx plus the constant. See, the students should have the habit of using the brackets wherever we are doing the multiplication or wherever the negative number comes. See, one thing I have observed, see in such case, many students, they don't use a bracket. So they simply write tan x into, they put a dot, write secant x plus tan x. Afterwards, they forget to multiply. See, both the terms have to be multiplied by tan x. They forget to multiply both of them. They multiply only one term. The other one they keep it as it is. Naturally, the whole problem goes off. Okay. So be careful. Or sometimes you may have a negative number. In that case also, make it a habit to write inside the bracket. When more than one term is there, then you have to write inside the bracket. Now, left hand side, no need that you change anything. Multiply the right hand side. It is, remove the bracket. It is tan x into, see there are two terms means we have to split it into two integrals. Secant x into tan x into dx plus tan x into tan x. What is that one? Tan square x into dx plus the constant. Now this is a standard integral. Integral of secant x tan x is secant x only, whereas tan square x is not a standard function, but using the second identity of trigonometry, it can be written as secant square x minus 1. So let me write that one. It is secant x into tan x into dx plus, if you write it as this formula, I hope remember this one, tan square x is secant square x minus 1. So I can split this also into two integrals, secant square x into dx minus 1 into dx plus the constant. Now all of them are in the standard form. I can go for integration. So y into secant x plus tan x. Don't do any simplification here and integrate. Secant x plus tan x is secant x, integral. For secant square x, it is tan x. For dx, it is x. and the c has to be written as it is. Now, of course, here also you can divide by this one, secant x plus tan x, then you can take it as 2 together, that would be divided by the same quantity 1, and you can write minus x divided by that. That even if you divide now, it won't be in any standard form, I mean it won't be any simplified form. So, there is no point in dividing. See, in the earlier problems, some of the earlier problems I did the division here, because when I did the division, the answer or the solution was comparatively in a simpler form. So, because of that one I had done the division there, but in this problem it is not necessary. Now, let me consider another problem, of course, which is not directly given in this form. As in the earlier problems, it is not directly given in that form, but you can bring it to that particular form here. Okay, you can bring it to that particular form by doing the at least by dividing or like this. Now, consider the problem: cos square x into dy by dx plus y is equal to tan x. Here also the same values for x have been specified. It lies between the closed open interval 0, 0 less than or equal to x less than pi by 2, or closed open interval 0 pi by 2. Now, look at this one. In all the earlier problems, I had considered dy by dx plus some function is equal to some other function. That means it was directly given in the standard form. Whereas here dy by dx is having a coefficient other than 1. So, to bring it to the standard form now, first step is you have to divide by cos square x, that is dy by dx, okay, plus first one you divide, of course both the terms here, both the sides, 1 by cos square x into y, and the right hand side is tan x divided by cos square x. I am dividing by cos square x, which is the coefficient of dy by dx. That is, I can write dy by dx plus 1 by cos square, as you know they are the reciprocal ratios, secant square x into y, and the right hand side is tan x into secant square x. Okay. Now, it is in the standard form. Now, what are the values here? P is equal to secant square x here, and Q is equal to tan x into secant square x. See here, the calculation would be more, because the right hand side, the value of Q is not only one function, it is a product of two functions here. Now, P is secant square x, Q is tan x into secant square x. What is our first problem? We have to consider integral P dx. That is, what is P here? Integral secant square x into dx. It is nothing but, it is a standard function, it is tan x. So, the integral P dx is tan x. Now, what is the integrating factor? It is e to the power integral P dx, that is e to the power tan x. I cannot do any simplification here, only e power some logarithmic function is there, I can use the information. It is e to the power tan x. Let me go to the solution directly. What's the solution? Y into the integrating factor, that is y into e to the power tan x. So, left hand side always it has to be kept as it is, because it is free from the integral sign. The right hand side is q. What is q? Q is tan x into secant square x. What is integrating factor? E to the power tan x into dx plus the constant. Here, let me rearrange the terms here. It is e to the power tan x into secant square x into dx plus the constant. Now, in this problem, the integration is a little bit lengthy, a little bit not a very easy integration here. Look at this one. Let us see what method of integration can be followed here. You know about three methods here. One is substitution method, the other one is integration by parts or integration by partial fraction. Here we have to make the substitution. We are having exponential function, trigonometric and secant square. Look at the terms. When you look at the terms only, you have to think what substitution, what method we have to adopt. We are having tan x and secant square x. By taking tan x to be equal to t, making the substitution, secant square x dx becomes automatically the derivative. So first let me make the substitution. Let tan x be equal to t. Then what is the derivative? Secant square x dx would be equal to dt. So see, on the left hand side I am not writing this one. Only for the sake of integration I am using the substitution. So the left hand side should be kept as it is. Y into e to the power tan x, that's equal to, you write e to the power t into tan x is t, secant square x into dx is dt plus the constant. Now look at this one, or I am rewriting this one, t into e to the power t into dt plus c. Now what method you can adopt here? It is a product. I cannot use any other method. It is integration by parts. Two different types of functions. One is algebraic, the other one is an exponential function. Apply the integration by parts. First function t into integral of the second, that is e power t only, minus integral of the second or e power t, the derivative of t, that is 1 into dt plus c, or it is a simple function t into e power t minus e to the power t plus the constant. Of course, left hand side I am writing the variable x only. Now what is t you have, or you can take out e power t as common factor also, so that the function can be written in if possible in a simple form, that is write like this, y into e to the power tan x equal to, take out e to the power t as common factor, t minus 1 plus the constant c. Now what is t you write, that is y into e to the power tan x, that is equal to e to the power tan x into tan x minus 1 plus the constant. Now we are having the same term here. So just to write y is equal to something, let me divide by e to the power tan x. So left hand side is y, here this is cancelled. What is remaining? Tan x minus 1 plus c divided by e to the power tan x. See, remember, division means all the terms have to be divided. So let me write the answer in a better way. It is tan x minus 1, take it to the numerator, c into e to the power minus tan x, using the law of the indices. Now this is the solution. That is, here see so many different methods I am using. I am using the first making the substitution. After making the substitution, it has come to the form of where I can make use of the integration by parts, and then replacing the original variable x here, I get the answer as y is equal to tan x minus 1 plus c into e to the power minus tan x. Okay. Now these are the problems we have discussed about the particular type linear differential equation. I am telling you again, it is given for a 5-mark question in your part D. So in the next session also, I am going to work out some more problems on linear differential equation, where I may find out the particular as well as the general solution. So we'll meet in the next session. Thank you.